Good morning, Ms. Lucy and everyone watching this presentation. Today, we from Group 13 are going to present the result of our project on data science. So yeah, we have done a project on analyzing a data set using Python on Jupyter Notebook. And this is the topic of our project, the impact of age and gender on heart disease. So let's start with the introduction. The background on why we took this topic is because heart diseases, also known as cardiovascular diseases or CVD, has become a major problem in the medical world. According to the World Health Organization, it has become the #1 cause of deaths worldwide. These diseases, in this context, includes their various classifications such as coronary heart disease, cerebrovascular disease, rheumatic heart disease, congenital heart disease, deep vein thrombosis, and pulmonary embolism. So cardiovascular diseases actually has so many risk factors. Mostly it is affected by behavioral patterns, such as how healthy your diet is, how physically active you are, whether or not you smoke, and how often you consume alcohol. However, there are actually so many underlying determinants, such as poverty, stress, and also hereditary factors. And if you look into it, most of the factors that I have mentioned earlier are indirectly affected by either age, gender, or both. For example, people of productive age are more physically active than the elderlies, but they are also more prone to stress than the elderlies and of children. And also, males tend to have a less unhealthy diet compared to women. We do not back this based on any scientific research or so. It's just based on logical reasoning and what we see on the daily. So this leads us questioning about the relationship between age and gender to heart disease. Next, we can go to the taxonomy mapping. So we get our data from Kaggle, which is from heart disease UCI. And the features in this data set consist of many attributes, actually. It includes age, sex, chest pain type, serum cholesterol in resting electrocardiographic results, maximum heart rate achieved, exercise-induced angina, old peak, the slope of the peak exercise, and also the number of major vessels. However, in this project, we only focus on two main features, which is age and sex. So we dive deeper into the two features instead of studying all the 14 features. For the data preprocessing, there are 5 steps to it, which include data cleaning, transformation, standardization, sampling, and then feature selection. And for the statistical methods, we use histogram or bar plot for each variable. We use correlation matrix, box plot, and also proportion. And for the machine learning, we use the algorithms. We use 3 algorithms, including logistic regression, KNN, and also random forest. And to measure the performance of our model, we used confusion matrix, ROC AUC, and also accuracy. So the number of deaths due to cardiovascular diseases, which we have discussed previously, becomes a problem in the medical world. These diseases cost the US healthcare system about $214 billion per year, only in US, and also costing an additional $138 billion lost in the productivity of the job. It is very important to raise people's awareness of the disease, especially to those who belong to the high-risk group. Therefore, the problem that we would like to solve here is whether or not age and gender influence the risk of heart disease. We are attempting to solve this by building a simple model to predict heart disease using logistic regression, KNN, and also random forest, and then measure its performance. And this leads us to the research questions. How does age and gender affect heart disease? In other words, our objective is to find out whether or not age and gender impacts on people's risk in developing a heart disease and implementing the discovered impact on the machine learning model.
Okay, thank you, Micheline. Now I will continue the presentation and present about our materials and methods of our project. Okay, next slide. Okay. The dataset we are using is the UCI heart disease from the popular UCI machine learning repository. This dataset is famously known as the Cleveland datasets. The dataset was originally consisted of 76 attributes, but all published experiments refer to using a subset of only 14 of them, although our experiment will only focus on two of them, which is sex and age. The targetal parameters refer to the presence of heart disease in the patient. Originally, experiments with the Cleveland database have concentrated on simply attempting to distinguish presence of values 1, 2, 3, and 4 from the absence of value 0. In our case, this has been simplified to further a 1 and 0 to denote presence and absence respectively. Next slide. Now we will analyze the features of our dataset. We have age, which is the patient's age in years. We have sex, the gender of our patients. We have CP, patient's chest pain type. We have stress BPS, patient's resting blood pressure. And next slide. We have CHOL, which is the serum cholesterol. We have FBS, the fasting blood sugar. We have REST ECG, the resting electrocardiographic result. We have TALAC, the maximum heart rate achieved. We have EXANG, which is exercise-induced angina. Angina is a medical term, the medical term for chest pain. Next slide. We have OLD peak, the ST depression induced by exercise relative to rest. We have slope, the slope of the peak exercise ST segment. And then next we have CA, the number of major vessels colored by fluoroscopy. And then we have THAL, which is the thallium stress result. Okay, next slide. And finally, the target feature that we are trying to predict is the patient's heart disease condition, where 0 indicates that they do not have heart disease, while 1 indicates that they have heart disease. Okay, next slide. Now for the next step, we will drop all the other columns other than sex and age, since we will be only focusing on trying to predict the impact of age and gender on heart disease. Next. We then convert the categorical feature of sex into two columns using one-hot encoding to better the result of the machine learning models. Next, we finally split the data into three parts, which is training, validation, and testing, with the ratio of 8, 1, and 1. Okay, next slide. Now for data preparation, we will see the features of our dataset. We can see that in our dataset, we have 303 rows of data, while we don't have any missing values for our dataset. So it is clean and ready for the next step, which is exploratory data analysis, or EDA. Okay, next slide. Now for EDA, our first analysis is age analysis. We can see that the youngest patient is age 29, while the oldest is 77. The mean age is 54 and the median age is 55. This shows that there are no particular outlier in the age feature. Next slide. Okay. Next, we categorize the data into groups of young patients that are under 40 years old, middle-aged patients that are above 40 years old, but under 55 years old, and elderly patients that are above 55 years old. We have found that middle-aged and elderly patients dominate the age demographic. Okay. Next slide. Okay, we then analyze our next feature of sex. Number of male patients is 207, while female patients is only 96. Based on that result, the number of male patients shown in our data set is 2 times bigger than female patients. Next slide. Now, for heart disease analysis, the number of heart disease or CVD sufferer is balanced with 165 patients having heart disease, while only 138 patients don't have heart disease. Now, we will analyze the spread of heart disease between age and gender feature. We can see that the age age and heart disease histogram that the dominating age is around middle age group and elderly of 50 years old and above, with a considerate amount below that as well. For the gender feature and heart disease, we can see that the dominating percentage is female patients with 75%, while only male patients having 44% of their demographic having heart disease. Okay, next slide. And for the next slide, in heat map, we can see that there are no clear correlation between one particular feature with another that can predict the outcome of target accurately. So we will need to use all three of them to predict the outcome of target in our models. Okay, next. Now I will pass it to Micheline to read the limitations.
So our project, of course, has limitations to the process and results. First of all, our dataset was gathered only from patients that went to the hospital to be checked or treated. So it doesn't represent people who have heart disease but do not come to the hospital due to their own reasons. That's our first limitation. And then secondly, our trained random forest is overfitting problem where the prediction accuracy is low compared to the accuracy on the... Wait, bagian sininya tuh nanti dipotong ya? Bentar, sorry. Kan nanti
Oke, apa,
tengah-tengahnya
bisa.
tuh... Oh bisa
Apa?
ya, sorry. Aku bingung bacanya, bentar. Tadi habis yang kamu IDE berarti lanjut ke si Atik ya?
Ya, harusnya Atik ngejelasin model, dia selesai baru
Terus
limitation.
Oke, bentar.
Go.
Mulai ya?
Yuk.
So, of course, our project still has limitations to the processes and the results. First of all, our data set was gathered from patients that went to the hospital to be checked or treated. So it doesn't represent people that actually have heart disease, but decided not to go to the hospital due to their own reasons. Second of all, our trained random forest model has overfitting problem where the accuracy of its prediction on other data sets other than the training data set is low. Moreover, the rest of the models during training have suboptimal results. Our hypothesis is because we are trying to predict whether or not someone has heart disease based merely on two vague parameters, which are sex and age. If one is trying to build such prediction model, the medical parameters we dropped previously, like resting ECG, cholesterol level, and so on, shall necessarily be taken into account.
Okay, now for future study, we have considered two future study to go on in the future. The first one is gender as a risk factor might alter at different stages of life. This could become a topic of future study. The second one is the heart disease on age visualization should be performed on probability basis rather on occurrence basis.
So to conclude, according to the results, female patients have higher percentage of heart disease sufferer than male, which means female are more susceptible to heart disease compared to male. Second, the highest occurrence of heart disease happens in middle-aged and elderly group of patients. And then third, the random forest model predicts the area under the ROC curve to be 74.38% while in training, which is arguably acceptable enough for having only two parameters, sex and age. But during testing, the model predicts the area under the ROC curve to be only 57.24%, which is way lower than the anticipated result due to overfitting of the model. And lastly, we concluded that sex predicts heart disease better than age, according to the heat map. So yeah, that's it for our presentation. Thank you for listening to us.
Thank you.
Thank you.